Hello everyone, welcome to my channel. In this video we are going to discuss about irrational numbers, the proof of irrationality of irrational numbers, and we will also do exercise 1.3. So let's get started. In 9th standard you have learned about irrational numbers and their properties. We know irrational numbers are the numbers which we cannot write in P upon Q form, where P and Q are integers and Q is not equal to 0. And also the square root, cube root, etc. of natural numbers are irrational number if their exact value cannot be obtained. Example, square root of 2, square root of 3, cube root of 3, all these are irrational numbers. Also, a non-terminating and non-recurring decimal is an irrational number. For example, 0.4243444546 and so on. 0.0100100001 and so on. This is also an irrational number. And we know the pi is also an irrational number. We have also learned that the sum or the difference of a rational and irrational number is always irrational, and the product and quotient of a non-zero rational and irrational number is also an irrational numbers. And to prove the irrationality of these irrational numbers, we use the fundamental theorem of arithmetic, and we use one more theorem to prove the irrationality of irrational numbers. According to this theorem, if P is a prime number and P divides A square, then P will also divide A, where A is a positive integer. So first question here is, prove square root of 2 is irrational. So to prove this, we'll use a technique which is known as proof by contradiction. For that, what will I do? I'll take this square root of 2 as a rational number. Let square root of 2 is a rational number. We know we can write a rational number as A upon B form, where A and B belongs to integers and B is not equal to 0. And the common factor between A and B is 1. So it means squaring both sides will get A upon B whole square. This will become 2, which is equal to A square upon B square. So I can write this as 2B square is equal to A square. Or I can write this as A square is equal to 2B square. So from here, see, A square is divisible by 2. Correct? So A is divisible by 2. And this statement I have taken from the theorem which I have explained to you before starting the proof for the irrationality of square root of 2. Correct? So it means I can write this as A is equal to 2C, where C is any integer. Squaring both sides, what will we get? A square is equal to 4C. 4C square. Let me mark this equation as my first equation, and I'll take this as my second equation. From 1 and 2. What we got? We'll get that 2B square is equal to 4C square. It means this will get cancelled with this. B square is equal to 2C square. Correct? Similarly here also. So here also, see, if B square is equal to 2C square, it means then B square is divisible by 2. So it means if B square is divisible by 2, then B is also divisible by 2. So this I'll mark as my equation 3. So from 1 and 3, we'll get that A and B. So from 1 and 3 we can find out that A and B have a one more factor 2 other than 1. So it contradicts our assumption that A upon B is a rational number. Why? Because A and B should not have a factor, common factor other than 1. So we can say that A upon B is not rational. This implies that square root of 2 is not rational. Or we can say that square root of 2 is irrational. Okay, this concept is by using the fundamental theorem of arithmetic and this theorem. If P is a prime number and P divides A square, then P divides A, where A is a positive integer. By using this theorem, we have proved that square root of 2 is a irrational. So we know that the product of a non-zero rational and an irrational number is always an irrational number. So let's see how we can prove the irrationality of such number. For that, I will take one example. Prove that 7 square root of 5 is irrational. So first we will take let 7 square root of 5 is rational. So then next step, we'll equate this A by B, because rational number we can write in this form A upon B. So here A and B belongs to integer and B is not equal to 0, and the common factor between A and B is 1. Okay, so now what we can do here, I can write this as this A, I can take this 7 down, this will become, now take square root of, so here see this A, B and 7, these are integers. So it means this A upon 7, A divided by 7, B is a rational number, correct? But if this is a rational number, then this implies square root of 5 is also a rational number. And here we can prove that square root of 5 is an irrational number, as we prove the irrationality of square root of 2. So this contradicts the fact that square root of 5 is irrational. So we can say that 7 square root of 5 is irrational. Okay, we know when we add a non-zero rational number and irrational number, we'll get irrational number. So let's prove the irrationality of such numbers. So let's take this example. Prove 3 plus 2 square root of 5 is irrational. So same steps we have to follow here. So first is, we'll say that let 3 plus 2 square root of 5 is rational. So it means we can write this number as P upon Q or A divided by B form, where A and B belongs to integer and B is not equal to 0, and the common factor between A and B is 1, correct? So I can write this as, I can take this 3 that side, so this will become 2 square root of 5, which is equal to A divided by B negative 3. So this will become A minus 3B upon B square root of 5. So this will become, I'll take this 2 down, so A minus 3B upon 2B. We know as A, B, 2, 3 are integer, it means that A minus 3B upon 2B is rational. If this whole thing is a rational, that square root of 5 is also rational. but we know the numbers like square root of 5 are irrational. So this contradicts the fact that square root of 5 is irrational. So we conclude that 3 plus 2 square root of 5 is irrational number. Next we also know the sum of one irrational number with another irrational number is always irrational number. So let's prove the irrationality of such numbers. For that, let's take one example. Show that square root of 2 plus square root of 3 is irrational. To prove this also we'll say let square root of 2 plus square root of 3 is rational. So it means we can write this as a upon b form, where a and b belongs to integer, b is not equal to 0, and the common factor between a and b is 1 only, correct? So it means I can write this as, I'll take this 3 that side, so this will become square root of 2 is equal to a upon b negative square root of 3. This will become square root of 3, b square root of 3 divided by b. This is like this, okay? This b I will take that side, this will become square root of 2 b is equal to a minus b square root of 3. Now squaring both sides, we'll get 2 into b square, a square minus 2ab square root of 3 plus 3b square. Now I'll take this and this that side, so this will become 2b square negative b square negative a square equal to minus ab square root of 3. So this will become b square plus a square, and this I can write here, which is equal to square root of 3. This and this, they will get cancelled. It means square root of 3 is equal to b square plus a square divided by 2ab. So here see a, b and 2 are integers. So it means b square plus a square divided by 2ab is a rational number. So if this whole thing is a rational number, it means square root of 3 is also rational. But we know, but square root of 3 is an irrational number, that we know. So this contradicts the fact that square root of 3 is irrational. So we conclude that square root of 2 plus square root of 3 is irrational, hence proved. Now let's do exercise 1.5. Here first question is, prove that square root of 5 is irrational. We will use same technique called proof by contradiction to prove this. So for that we'll take let the square root of 5 is rational number. Okay, if this is a rational number, so we can write this as a upon b form, where a and b are integers and b is not equal to 0, and the common factor between a and b is 1. Okay, so I'll take this b that side, it will become b square root of 5 this, and now squaring both sides, we'll get 5 is equals to a square. So we can rewrite this as a square is equal to 5b square. So here we will use this theorem. If 5 divides a square, then 5 will divides a also. So it means we can write this as a is equals to 5c. C is any integer. Okay, I'll take this as my equation number 1 and this is equation number 2. So squaring both sides, both sides, we'll get a square is equal to 25c square. Correct? So this is my equation number 3. So comparing equation 1 and 2, from 1 and 3, we'll get 5b square is equals to 25c square. So this will become b square is equals to 5c square. So here same. So here we can say that 5 divides b square from here. So it means 5 divides b also. So, and we know that 5 divides a also. It means a and b has one more common factor, 5. Okay, and but this contradicts the fact that a and b has no common factors other than 1. So this contradiction arises because of our incorrect assumption that square root of 5 is rational. So we conclude that square root of 5 is irrational number. So second question here we have proved that 3 plus 2 square root of 5 is irrational. This question we have already done. So do it yourself. So third question here we have proved that the following are irrational. First is 1 divided by square root of 2. Second question is this. We have done this question earlier, so do it yourself, and we'll do these two questions, first and third. So first question here is 1 divided by square root of 2. Same we'll assume let 1 divided by square root of 2 is a rational number. So we can write this number as a upon b form. Correct? So a and b are integers and b is not equal to 0, and the common factor between a and b is 1. So here I can cross multiply and I'll get b a square root of 2. So I can write this as, I'll take this a that side, so it will become, we can write this as square root of 2 is equal to b upon a. Like this also we can. Now squaring both sides, we'll get b square is equal to a square and 2. So it means we can write this as 2a square. So from here we can say that 2 divides b square. So this implies 2 divides b also. So we can write this as b is equal to 2c, and c is any integer. I'll mark this equation my 1, and here I'll take square both sides. B square is equal to 4c square. Correct? So now compare 1 and 2. Comparing 1 and 2, we'll get 2a square is equal to 4c square. Implies this will get cancelled. A square is equal to 2c square. So it implies that from here we can say that 2 divides a square. Implies 2 will divide a also. Correct? So I'll take this as my equation 3. So here we can say that a and b has one more common factor, 2. So this contradicts the fact that a and b has no common factor other than 1. So this contradiction is due to our incorrect assumption that 1 divided by square root of 2 is rational. So we can say that 1 divided by 2 is irrational. This implies 1 divided by 2 square root of 2 is irrational. So hence proved. So for third question, similarly we have to take let 6 plus square root of 2 is a rational number. Correct? So we can write this number as a upon b form, where a and b are integers and b is not equal to 0, and common factor between a and b is 1. So here also we can rewrite this as square root of 2. I'll take this 6 that side, minus 6 upon b. So this will become a minus 6b divided by b, square root of 2. Correct? So here, from here, see. So from here we can see a and b are integers. So this implies this thing is rational number. If this whole thing is a rational number, then square root of 2 is also rational. But we know that square root of 2 is irrational. But we know that square root of 2 is irrational number. So this contradiction is due to our incorrect assumption that 6 plus square root of 2 is rational. So we can say that 6 plus 2 square root of 2 is irrational number. Hence proved. So with this we have completed exercise 1.3. Thank you everyone for watching my video.